Hello Internet! In this video we are going to be looking into MonoGame. So MonoGame is the open source derivative, I guess, of XNA. So XNA was built as sort of a DirectX 9 framework. So it was designed so you could build games really easily using a lot of the DirectX 9 stuff, and you could use it in pretty much any .NET language. MonoGame came afterwards and was kind of built on top of that in Mono. And what that did is sort of bring it everywhere. So prior to like .NET Core, C# and all of that did not run anywhere besides Windows. And so if you wanted to do that, you would use Mono. And so that's sort of where MonoGame gets its name. And it's pretty much, XNA has not been supported for a number of years now. I think it went out in like 2014 or something. So a few years ago, XNA has stopped being supported by Microsoft. So if you wanted to continue working on XNA, then this is what you used. So yeah, as you can see, there's a number of different project types because you can build for almost anything. It's got almost the same platform compatibility as like Unity or any other games. I think it's got more actually. I may have to check that, but this isn't all of them. You can target pretty much any game platform you want. All of the major game consoles. I think they even did things for like the Ouya and things like that. But anyway, this is not the first time I have been recording this video. I recorded it yesterday, but I didn't turn my mic on. So I have like 30 minutes of footage for this. This one's going to go way faster because I actually know what I'm doing now. But yeah, so we're going to redo what I did yesterday. So yesterday was interesting because I hadn't touched XNA or MonoGame in almost 3 years. The last time I used it was with Zune, which actually, no, it was Xbox 360. So Zune was the only way you could make an app for the Zune was if you built it in XNA and then sideloaded it. They didn't have an app store. Well, they did, but you had to be pre-approved by Microsoft to get your app into the store, which meant there were only about like 40 apps total throughout the entire life of the Zune. And so if you wanted to get other apps, you had to build them in XNA and then load them yourself onto your own device. So you'd sideload the actual binary file and deploy it yourself and all of that. So that's sort of where I learned XNA. And then I brought it with the Xbox Live Arcade. A lot of those games were also built with XNA. So that's where a lot of this is coming from. So we're just going to build a really simple application to kind of show you what this looks like because it's very different. I wouldn't say MonoGame is a game engine. It's a game framework. And my definition between those two is a framework kind of lets you like, it gives you the what you need to like draw something to the screen, but it doesn't provide you those tools and other things you might need for, say, physics. If you want physics in MonoGame, you have to find a physics library and bring it in. If you want animation, you have to find or build your own animation library and then implement that. And you'll see that makes this very, very easy and very adaptable. You can do almost anything you want because it's pretty simple. We probably won't write very many lines of code here. So the goal here, we're just going to create a simple program that's going to have a single sprite that's going to bounce around our screen, sort of like those old TV screensavers. So you'll just have, I'm thinking like the World of Zero logo will just appear and then sort of bounce around the screen whenever it hits the side. And that will sort of be that. It'll kind of demonstrate some loading and a few other things. Nothing super complex. If you've used XNA or MonoGame before, it's not going to be anything new. There is, yesterday I was learning, there is actually a new content pipeline, which was one of the things I didn't like about MonoGame. XNA used to have a content pipeline built into Visual Studio, so it'd actually build your assets for you and actually compile them into a binary form, so all of your images and your models and stuff would get compiled, and then you could load those. MonoGame didn't have that, so you'd have to build them and then like import the binaries somehow, and it was a mess. They've since built their own pipeline. I don't know how old that is, but it wasn't there last time I used it, so it's new, and it actually works really well. So I'm gonna just create this project here, and we'll get started. You won't see in Visual Studio, you won't see all of those new project things that I was showing. You need to go and download MonoGame from their website, and that will work in pretty much any Visual Studio that is still relevant. I think it goes back to like 2008, so Visual Studio 2008 all the way up to 2017. And this is our project. So we get 2 C# classes, a game icon. This will just be the icon displayed for it. And then we get this content folder, which is going to be where all of our visual assets are stored. So sprites or textures or anything like that. So this is the entirety of our game. And I'll just walk you quickly through how this whole thing works. So first off, you create your game. That's easy enough. That's done here. And really all that happens is you create a new game, just game 1, and then you just run it. And that's your main thread. That's it. And so once you get into that, this just does an infinite loop that takes over that thread and just constantly gets into a draw and update loop. So how that happens is you create your game. This kind of sets up a graphics device manager, which is used for managing your graphics stuff. Then it initializes. So this would be where you'd initialize any like configurations or things like that. And then you load your content. So this will be visual assets, so sprites and things like that. This is where you'd load them. I'll show you how to do that in a second. If you need to unload them, you do that here. And then you get into the update and draw loops. And this is as basic as it gets. There's no objects here. There's no anything. If you want like objects that have like positions and things that you can manipulate, you have to define that yourself. You don't get any of that here. You do have like vectors and stuff that you can work with, but this is literally your game. It's got an update. The default just includes a way to press like escape to quit. And then it's got a draw, which is just currently going to clear it to this cornflower blue, which is just this gross default blue color. And then it just draws it. And it looks like it's passing in a game time object, so we can actually get like a delta. And that's it. That's everything you get. There's a few things happening up here. This is setting up your content root directory, which is going to point to where your content is. So this is saying look in a folder called content for content. So that's pointing here. And that's about it. There's nothing else here. So if you start this, you get this. Once it goes, you get this. So just basic blue screen. And that is the wonderful cornflower blue. So pretty much every default MonoGame project or XNA project looks like this. And if you want to like change this to say black, so this will clear our entire screen and make it black. That's all you have to do. So this clear effectively goes to every pixel inside of your screen and says make it black. And this is going to be a per pixel, I want to say, thing. So it just goes and clears your graphics buffer with whatever that is. So what we need is we need a sprite that we can load in. And then we need to track its position and then have it actually bounce. So give it a velocity and bounce it off of things. So what I'm going to do is just add, not this. Let me grab a image quickly and drop it in here. So I'm just going to take like a PNG file and drop it into this content. And then we'll pick up from there. Okay, so I have pulled in just a World of Zero logo. This is just sort of the default one. It's huge. I don't know the scale it's at right now, but I imagine it's quite tiny. I have these at like massive resolution just because I use them everywhere. Yeah, so this is 100%. So this image is massive, really big. We don't need it this big, but it's that big just because. So what we need to do is load it into here. So this is sort of a separate project, which defines sort of our content thing. So when you install MonoGame, you get this other thing called the content pipeline. Let me grab that quickly. So that's going to look like this. So this is the MonoGame pipeline tool. And we just need to drag that in, I think. No. Okay. I'm going to go open this up. We just need to open that file. So yeah, one sec. Let me grab that. All right. So all you have to do is point that open dialog at this file, and you'll see it open there. Then we should be able to, nope. Okay. So we need to add a new item. So I'm going to actually add an existing item to this content project by doing that. And I'm already in the directory, so I can just click the World of Zero logo. I'm actually going to rename this and just so it's easier to find. I don't like spaces. It just makes everything more difficult. And Linux really doesn't like spaces. So yeah, we're going to drop that in. And then we just need to build it. So this will build everything. We'll see it succeeds, which means this will change. And so we get a whole bunch of this stuff, which is going to color key it. So color keyed sprites, even if you have, what's a good example of this? If you have like a sprite sheet, for example, without having a separate layer for your alpha, you can actually color key something. This is going to be like purple, that like classic ugly purple, that sort of like fuchsia purple. Anyway, it's going to be that purple, and effectively every pixel that matches this color exactly is cut from your image and is actually just made transparent. So when you're going for like pixel perfect things with no like smooth transparency or anything, this works really well. But everything else, this is just classic stuff. It's just kind of pointing to where everything is. And so now that we have done that, I'm gonna make this match because it doesn't rename it in the solution, cannot be found. Okay, it really doesn't rename it in the solution, so I'm gonna just, okay. Yeah. That was weird. Sure, it's gone now. We don't, oh, we probably wanted that. Let me, sorry. Got a little bit distracted. Let's add that back in. I don't know why the name change didn't sync up, but when I renamed it in Explorer, Visual Studio did not see that, and that caused a few issues. Anyway, everything should be good now. We have this image defined here, which means we'll actually be able to find it in our content loading. And so the way that works is you do something like this .content .load, and we want to load a texture 2D called something, called our World of Zero logo. So this string here is going to match that bit. I don't think, I said I did this yesterday, but I still don't remember. I don't think you need the file extension. I might eat my words on that, but I'm pretty sure you don't. So with this, that gets compiled into here. And then in our game, we're actually going to load that in. So I'm going to save this texture here. And this will just be logo, sure. So we want our logo equal to that. And then I just want to draw it. So the way this works is you use what's called a Sprite Batch. So this is like a sprite group. So everything in this Sprite Batch is kind of drawn as a layer. So if you want multiple layers, you create multiple Sprite Batches. That's not how that works. We already have one created. By default, you get a sprite batch created because you can't really draw anything without it. And this sort of defines what you're drawing and where. So we are going to begin and end. So begin is going to sort of start the batch, and then when you end it, that's actually going to draw it. So we want to draw. And this is going to just draw our logo. And that is all I need. I don't need anything else. Everything else can be defaulted. So this will be in the top left corner. It won't have any rotation or anything like that. We'll walk through what some of those other parameters mean. But this should draw our logo in the top left. It's a huge logo, so it's going to go way off the screen, but that's fine. I lied. So it's either expecting a draw rectangle or a position. So if we give it a draw rectangle, that's going to give it a top, a left, a right, and a bottom, I think. And so you kind of define like a square and say, put it in this square. If you give it a position, it will draw it at the current size of the image, and we'll kind of just scale it however you do it. There's a separate scale option, so we can actually go through what some of these mean. It doesn't seem to want to. No, okay, fine. There's a way to pull back up the IntelliSense here, but I am totally blanking on it. Let's do it this way. Okay, or not. Sorry about that. We're gonna just give it a vector2.0. So this will be top left again. I'm just gonna use named parameters here because I don't necessarily keep track of the order of things, and it's just way easier this way. So this way, we are drawing that logo in the top left at position 0, 0, so it'll start at pixel 0, 0. And the origin of these sprites by default is actually in the top left, which means it's going to be in the top left and go down like this. So our window isn't resizable, but you can kind of see our logo starting there. I think the screen is 800 by 600. That might be wrong, but anyway, we're getting something. So what I want to do is have two targets. So a target X, and I'll set that equal to like 128, and a target Y, and I won't set that one. That one's going to be derived from this formula. So we're going to calculate a scale so that our image is 128 pixels wide. And then based on that, we're going to calculate how many pixels high it will be. And that way we can actually detect when it goes off the screen or not. And then we're going to do just a vector2 for our scale. And that's not going to be set either. We can set all of that up here. So this isn't really the best project layout. That's not really the point of this video. It's strictly just to kind of introduce you to some of this stuff. If you're interested in like writing game engines, for example, this is a much better place to start than something like Unity. Unity is a good place to like learn game development and that kind of thing. And it's a really great place to like build a game. But this is here you kind of have to care about like your architecture and stuff because you're the one that's going to be maintaining it. So like I'm sticking pretty much everything in this load content. If a game actually did that and it started expanding, this would get unmaintainable really quickly. So there's some learning that is interesting. So what we're going to do is create a scale here that's equal to a new vector2, which is going to be 128, not 100, the target X divided by our logo's width. So that's going to be the number of pixels wide it is. So everything here we're measuring in pixels. And we're just going to do that again. And so our target width, or target X, is already a float. I'm just going to convert this logo to a float as well. And this way, even because this is a pixel technically, so it'd be kind of confusing if you were dividing a pixel by a pixel and you got a floating point number, that's confusing to me. So we're gonna just stick a float in there, even though it's saying this is already handled. I'm gonna do that anyway, just because I like to. Then we need to calculate our target Y. This isn't really required yet, but it will be, so we're gonna go for it. And this is going to be equal to our logo.height times the scale.y. So we're taking the total height, and then we're just scaling that down and setting that to our y. And then here, we just need to pass in our scale. So our scale is equal to our scale. And then I should be able to draw this, and our logo should be smaller. So now it's 128 pixels wide. It kind of looks very aliased, and that's because it just will. We haven't done anything to kind of deal with that yet. So like these edges are not smooth at all, but that's fine. So the only other thing we have to do is kind of move this around now. So it's going to start up there, and then I want it to bounce off of every side. So whenever it hits a side, it's just going to invert the velocity on that side. So we will start it with a basic velocity. Velocity equals new vector 2, 1 and 1. We're also going to give it a position because we don't have that yet. We're just using the 0 vector. That won't work. So we're going to do a new vector 2. Ooh. That was weird. 0 and 0. So we have a position and a velocity now. And I didn't do this last time, but I'm thinking it might make sense to do this per second now. Last time I just did it per frame, but let's actually pretend like this is per second. So it'll move, that's probably too few. It'll move 100 pixels per second. So if I was correct and it's 600 pixels tall, that'll take about 6 seconds for it to get down. A little bit less because we aren't factoring in the total height here. So since our image is a little bit less tall, it's probably going to take closer to 5 seconds, but we'll figure that out later. So in our update now, we are going to want to take the position and add the velocity times game time dot elapsed game time dot total seconds. It's been a while since I've done this, so this might be a little bit janky, but so there's two things you get in a time span. You get like seconds and you get total seconds. And so the difference between that is if you get the seconds, say you have a longer time span that is like 6 hours, 30 minutes, and 6 seconds. If you just do seconds, that's going to return 6. If you do total seconds, it's going to get you the total duration of that entire time span as seconds, which is what we want. Because if I just did seconds here, it would return 0, which isn't helpful in the slightest. So that's something to keep in mind. Then we add our velocity. We've got our position here. I just need to swap this out for our position. And now, assuming I did everything right, it should start at the top and it should go off the bottom of the screen, going a little bit across the right. Sort of like that. And it'll just keep going. And we haven't implemented the bounce or anything yet, but that's sort of what we need. So now we just need to calculate the position of it and subtract that from, or compare that to the position of the screen. So there's an X and a Y, or a width and a height of our screen that we're going to need to calculate this. But for now, we should be able to do the top and the left sides. So position.x, if that's less than 0, and our velocity is less than 0, let's say less than or equal to 0, and our velocity is less than 0, so it's moving to the left, and it's off the left side, then we want the velocity times equal to the -1. So we're inverting our velocity. That's not right. Velocity dot x times equals -1. And they store their vectors as classes, which means we can do this. All right. Dot x. There we go. And then we just need one for if the position dot y is less than 0 and the velocity dot y is less than 0. We're going to do the same thing with our y velocity and just invert that as well. So this is going to change the direction if we hit the top or the left, which we hit neither of those right now. So this did absolutely nothing. But that's fine. The other thing we need is if the position.x is greater than or equal to some value. I'm just going to guess here. I'll show you how to actually get these in a second. But for now, we can actually just assume the height and width that I've set up. And then velocity times equals -1. And so theoretically, we could actually combine these two statements. So this and this, both are just going to invert our x. We could stick stick an or in between here. I'm not, because it just makes this more complicated, and for something this basic, I think there's probably more complexity that we're introducing that we just don't need to. So I'm going to multiply that, and I forgot to add our x. We don't want to flip the entire velocity, we just want to flip either the x or the y. So I'm going to do this, and that should be good, assuming the calculations are correct. So this should go, it should hit the bottom, and then it should bounce back up. And it does. A little bit of a delay there, and the delay is caused by this isn't factoring in the width of the sprite or the height of the sprite. So even if these are correct, they're not correct. We actually need to subtract the target x and the target y. Oops, target y. There we go. So this should be closer to correct. And so it shouldn't go off the screen this time. It should... I don't think that's 600 pixels tall. I'm going to say that right now because that didn't make any sense. How would I check that? There's a way to check that. There's a way to set that. And I don't know what it is. So this doesn't really particularly matter. This is more just for my curiosity. Because I don't actually know where the default width and height are set up. And I kind of want to find that. So I thought it was 800 by 600, but that I don't think that's the case if it went off the screen. Whatever. It doesn't particularly matter because we're going to swap this out for the actual height of the screen. So we're going to do graphics dot graphics device dot adapter dot, ooh, that's not right. There is a way to get the width, and I always forget how to do this. Every single time, it's like required that you forget how to get the width of your display. Where is it? Shoot. Yeah, I didn't think so. Graphics, device profile. That's not right. I'm pretty sure, like 98% sure, it's in this graphics device thing. But I don't remember. Viewport. Got it. Every single time. Okay. So we're going to use the viewport width. there's a few tricks to the viewport. It isn't actually necessarily the entire size of the screen. Viewport works kind of like in Pokemon, for example, or any of those other top-down games where you have like a camera that kind of moves around. That's sort of what a viewport does. There's actually more to this. So if I just bring this up here, there's actually an X position and a Y position. It's actually got some like safe area calculations for like big screen TVs. So you can actually have a safe area so you don't draw UI that might get clipped by the bezel or something of the device. But anyway, there's this X and Y, so you can actually move this viewport around, and it will only draw things underneath it. You have to kind of handle the culling and stuff yourself, but that's an option, so you can kind of move the screen around if you're doing like an RPG or whatever. Anyway, that was a random tangent, but this width and height are going to be, since we have just the viewport as the whole screen right now, that's perfectly fine for what we're doing. And this should work now. It shouldn't go off the screen unless, yeah, awesome. Okay, I was a little bit hopeful I didn't screw anything up. But yeah, this is a super basic example of what you can do in MonoGame. Obviously, there's nothing crazy going on here, but it shows you how to load things. It shows you how to do basic game loop stuff. There's nothing crazy going on here, but it is really powerful. There's a lot of really awesome games made in XNA and MonoGame. I won't list them here because there's a lot, but they're like games that you know are made with MonoGame. So it's not some obscure thing, and it's not that crazy, and it's actually super powerful too. Like this looks super simple, but it's also like really easy to change. Like we have full control over our update loop, over our draw, and anything else. And we can do both 2D and 3D graphics and get them running on pretty much any platform. We can run this on iOS, on Android, anywhere. So it's super, super useful. Not as plug and play as like Unity, because Unity has a lot of that stuff already built for you. But if you're looking to get into more of like the nitty gritty stuff, the back end of game stuff, this is a great place to start. And if you're familiar with like C#, it's all C#, so you're good to go. So yeah, this is MonoGame. I'm intending to do a lot more on this kind of thing. I have a whole list of game engines I want to go through, just because I don't know, there's everything does it just a little bit differently. Even if they're like fairly similar, they all have slightly different ways of approaching things. MonoGame is totally different than Unity, but there's certain things that are very similar. And those kind of contrasts actually kind of help you figure out what do you like and what do you not like what works versus what doesn't. And that's really cool. I really like that. So expect more of these like game engine things. Maybe we won't build a game in all of these, but at least like this kind of example, so you can kind of know enough to get started and kind of explore it yourself. So yeah, this is MonoGame. If there's anything else you guys want to see or any ideas you have for where we could take this, let me know. I'm always looking for ideas. Anything else, any feedback you have for me or the channel, leave it in the comments. I don't mind criticism or comments or anything like that, so don't hold back. But yeah, that's it for now, so I'll see you guys in the next one. See you, internet.